Okay, there, ladies and gentlemen, welcome to part two of today's lesson. First, let's talk about this crazy thing I had you guys write. Now, this is a vertical angle theorem proof that we wrote together. In fact, we actually kind of wrote it twice. Once kind of really messily, and then the second time we did a whole lot more formally using Cornell notes. And if you look really carefully, and I retyped it, I put this on Edmodo, so certainly if you didn't catch that, it's on Edmodo. You're welcome to download them and kind of convert them to your own notes. Uh, you know, we had a main complaint about this. And the main complaint we got about this, and we meaning Mr. Collins, is the amount that you actually had to write to accomplish this proof. That is a valid point. And in fact, at least two students came to me afterwards and pointed out that if you look at how I'm structuring this proof, there is a lot of repetition. There's a lot of stuff that we don't actually need because we're just repeating it. And furthermore, there's stuff we don't need because, well, it's just like it's an assumed part. Like take this statement right here that the hand is moving over. Like see this angle A and angle C are linear pairs. Well, why in the world do we even have to write that? Because it's the hypothesis. If they weren't linear pairs, then what's the point of talking about them anyway? And that's kind of how I feel about this proof as well. Now, this proof is a valid proof. In fact, if I would say anything about this proof, I would call this like a paragraph style proof. So like if it's more conversational. It's like two people were talking to one another, and someone's like, "Hey, what do you think would happen if angle A and angle C were linear pairs? Do you think that angle A and angle C would be supplementary because of linear pair postulate?" And the guy's like, "Yeah, that's what it would be." And you know what? If angle A and angle C were supplementary, then you know what? Angle A plus angle C would equal 180 because the definition is supplementary. And then the guy'd be like, "Yeah." So paragraph proofs are very conversational. They're extremely sophisticated. They're actually the type of proof you'll encounter if you kind of take a mathematics course in college, or let's say a pathway, because this is how mathematical textbooks are actually written. It's nice. It's a little bit repetitive. It's a lot to write, but I think we can probably accomplish the goal by writing like a whole lot less. So we're about to write a proof together, okay? And it's on the page behind me. But I want you guys to take special note that we're still going to be going through the process that's going to be the same. So I'm still going to do a brainstorm in which I identify what do I have to prove and what I have to actually do it. I'm going to make sure I have a nice visual representation of the proof. That's kind of like our outline phase. I'm still going to write as good of a plan as I can, just a really rough draft to kind of telling me where I need to go in my proof if I ever kind of like lose myself. And then I'm gonna structure a very formal proof. But again, the formal proof is going to look a little bit different because, well, I'm going to write in a whole different style, kind of in the same way that like different authors have a style, different proof writers do too. So this is a proof I want you to write. You probably want to take a second and either screen cap this and move it to like a piece of paper, or possibly, excuse me, or put in Notability. However you kind of choose to do this. Hopefully by now you've worked out a nice strategy where maybe you and a friend are sharing the video while you guys are writing. Lots of different ways to accomplish this, but there you have it. This is a proof of writing together. Okay. So let's get to it. So the first step in this proofwriting process is that we have to figure out what we're being asked to prove and, well, how we're going to prove it. So what I would do is actually drop down to this proof statement and make a realization that I'm asked to prove that triangle ABC is congruent to triangle EDC in our diagram. And notice I marked those intentionally in color. If you're doing this in Notability, you're going to transfer this later in Notability. I encourage you to do so as well. Okay. Excuse me. So now, if we know we're proving triangle is congruent, something should pop in our mind immediately. Like the first thing that should pop in our head is I'm gonna prove these by ASA, side side side, angle angle side, or side angle side. Those are the conditions for congruency we establish for triangles. So if I'm going to prove these triangles are congruent, I have to meet one of those conditions. Well, I don't have any information yet, so now it's time to get to work. So now it's time to do the kind of outline phase of this, augment our diagram, and make sure that we have enough information to meet these conditions. So check this out. We have BD bisects AE. In other words, AE is cut directly in half. Well, if BD bisects AE, i.e. cutting it in half, that would make these two things congruent. This is good news for us because this provides a side in both triangles that are both corresponding and congruent. We have AE that cuts BD in half as well. Now we don't know it's the same size, so we're going to use 2 tick marks instead of 1. But again, because it's been bisected, we have a second set of sides. Bam! Okay, so we're pretty good. Let's do a little triage here. We have 2 side lengths that we know for sure from our givens. So that's going to eliminate some possibilities. We're probably not going to use angle, angle, side, or angle, side, angle to prove these triangles are congruent because we only have we already have 2 sides, so we're not going to try to find 2 angles. But instead, now we're going to focus on what other information can I glean from the diagram. If I want to use side, 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 that means I'd have to be able to prove that this side and this side are congruent. Now, I may think they are, they may look it, but the question I'm asking myself now is, do I actually have a reason to make them congruent? And the answer is no, I don't. I don't have anything that proves those are congruent other than my own will, and then my will is not strong enough to make something like that happen. So we have to go elsewhere. So if side, side, side is not the answer, that means side, angle, side has to be, which means I have to somehow prove that the angles in the middle at C are both congruent, and in fact they are. If you look, these are actually vertical angles, and then by definition, those vertical angles are congruent. So I'm going to do something a little bit different here, and you're going to see me do this quite a bit in proofs moving forward. I personally get confused talking about angles when you start saying like BCA, ACB, ECD, DCA, EDC, C whatever, right? So what I'm going to do instead is go through my diagram and actually relabel some of these. I'm just going to call this angle 1 and angle 2. Now that's a perfectly okay thing to do. You can call them angle 1 and angle 2, happy face, squishy face. You can call it angle A and angle B. The general rule here is you just don't want to call it something that's already being used in the diagram. So if I want to call these angles by like a letter, I'm not going to use like A, B, C, D, or E because they're already being used and that can get confusing. But here's the good news. I do have now enough to prove congruency. I have side, angle, side. I have a side that runs into an angle that runs into a side length in both triangles. Therefore, side, angle, side is a condition that I've met. So I've now completed my brainstorm and really even my outline phase. Now what I need to do is kind of rough this out into a nice rough draft, hence rough. So what you're going to see here is like a simplistic version of what the proof is going to look like. The point of this is simply to give us kind of like a plan to follow in case we get stuck later. So here's the deal. If I want to prove triangle ABC is congruent to triangle EDC, what I have to prove to force that to happen is really going to be side angle side. If I can prove side angle side, I can prove the triangle is congruent. Okay. So now I have to ask myself, well, what in the world can I do to prove side angle side? Well, I roughed it out actually in my picture. If I want to prove side 1, I can point out that AC is congruent to CE, and that's going to become because of some kind of bisection. And I know that because, well, it tells me right here that AE has been cut in half. If I want to find information about the angle, which will be like angle 1 and angle 2, that's going to be the result of some level of vertical angle theorem because, well, they're vertical angles. And of course, if I want to talk about side 2, let's see, that would be BC and CD. I think I'm going to have to talk about some kind of bisection as well. And again, I'm going to point out in my givens, I can tell right away that BD has been cut in half. So if I combine these 3 pieces of information, if I combine piece of information 1 with 2 and with 3, that would give me SAS. If I have SAS, that tells me my triangles have to be congruent, and we're done because that's what our proof statement actually says. So this is what our proof is going to actually do. It's going to take and show that we have side angle side in both triangles. That will force my triangles to be congruent, which will force, which will force SAS. SAS forces my triangles to be congruent. And that would be it, guys. Let's go ahead and write this proof. Now, as a warning, I told you I'm going to write this in a different style. This style is going to be that of a flow proof. So what I mean by flow proof, I mean it's no different than like a flow chart like you'd see on the internet. Like, so if you search like flow charts on the internet, and you're welcome to pause the video right now while you do so. Ooh, sorry, I paused and then I yawned. So if you look at flowcharts on the internet, you see that it's a very particular style that's driven by arrows. And really, what I drew right here is actually a flow chart. So this proof is going to do nothing more than take this rough draft and really refine it. It's going to look very similar. It's going to have arrows, and it's going to be pointing down into where you should be looking next. Um, but it is a formal proof. It's a legit kind of proof. It's actually the proof I write the most. So let's go ahead and get started. So the first thing we have to do, which I'm going to box over in blue, is to show that I have side angle side, which will give me my congruent triangle. So here's how I'm going to set this up. So to prove triangle ABC is congruent to triangle EDC by side angle side, dot, dot, dot. I'm going to set up a side angle and side. Okay, and now I'm just going to start identifying the pieces. So side 1, I said was going to be right here. It says that I need to prove AC and CE is a result of a bisection. So here's the deal, and here's what's going to be really hard for you guys to kind of absorb. I can't make that statement yet. I cannot write in this space right here. I cannot write that AC and CE are congruent because of the definition of bisection. If you look at the definition of bisection, I'll go back to it. The definition of bisection says that two pieces are congruent. But what I haven't done yet in my story is actually confirm that I have a bisection. Now you're saying, well, wait, Mr. Collins, it says it right here there's a bisection. We drew it here that there's a bisection. We said here it's a bisection. But you know what? We haven't said it in our actual proof yet. We planned on it, we know it, we saw it, but we haven't written about it yet, not in our proof. So the first thing I'm actually going to do here is identify that we have a bisection. I'm going to write BD, I'm going to write in a normal color, excuse me, that BD bisects AE. Now, since it's in my proof, I do have to give you a reason. So the because part is going to be because it was given to us. It was part of our initial statement. This is an important step, and the reason it's an important step, as I'm putting a box around this to separate it from everything else, it's an important step simply because it tells us that we do have a bisector, that we're working with a bisector, okay? So if we have this bisector, we can immediately conclude that AC is congruent to CE. And that's going to be because the definition of bisector. So again, we have to represent our chain here, and our chain says that if I have a bisection, then those pieces are congruent. That does take two steps. If you were to leave this part out, I'm just going to cut it out temporarily. If I were to take this part out of it, all you'd have is that they're the result of a bisector, which leaves an open question. Well, how do you know they're bisected? You never said they're bisected. It's like starting in chapter 3 of a book. But if I put this part in, then immediately that question disappears. AC and CE are congruent because of bisector. Well, how do you know it's a bisector? Well, because it was given to us. So we've proven the side part of side angle side. Let's prove the angle part. So the angle part, according to our plan, if you look back at our plan, the angle part was the result of vertical angles. Now this is something we can directly state because it was in our diagram to begin with. We can't dispute vertical angles. Therefore, those are congruent by the vertical angle theorem, and we are done. Lastly, let's talk about side 2. This looks like it's going to be a carbon copy for the first one. First, we have to identify that there's a bisection happening. DB bisects. Oh, excuse me, I have it backwards. I apologize. Okay. I have AE bisects BD. Okay? And that's because of given. Okay. Because BD is cut in half, I can claim that BC is congruent to CD. And that's because of what it means to be actually a bisector. So if I look at my plan, I've now proven side angle side, which means I can directly claim that the triangles are congruent. Take a look how I'm going to do this. If I take this piece of information, which I'm going to draw with an arrow, and this piece of information, which I'll connect with an arrow, and this one, I can claim that triangle ABC is congruent to triangle EDC by the side angle side triangle congruence theorem. Okay. So I think we fulfilled our plan. Okay, and our plan was to find side angle side, to use side angle side to prove congruency, and we did that. Here is side angle side being proven for sides for each individual piece. That concludes our triangles are congruent. So this is a good proof. We can write off on it, QED. Everything I stated is true. That's what QED actually kind of means. And that is that. Now that took a while because we were talking a lot through it, but that's how long proofs take sometimes. And that's just the bottom line, right? So this is an example you can use. You don't have to write it in this style if you don't want to. You're welcome to write it in the paragraph style, and actually you're welcome to kind of decide what style you like and make up your own. That's totally cool with me. So your assignment for the rest of the day is you're going to be given, you have to go to the Google Drive. You have to go to the Google Drive right now. Well, actually after the movie. And download from today's file, November 22nd, a packet of 6 proofs. You're going to find 2 things in that folder. You're going to find the proofs, and you're also going to find a series of links, both QR coded and directly linked, out to the keys, because I don't want to leave you guys hanging and just struggling. I want to make sure you guys have a good sense of what to do. Now, of course, just don't copy it. If you're just watching the movies or just jumping to the key, it's not going to help you. But what you can do is try it yourself when you get stuck, look at the video and get past the part you're stuck and keep on working. I'm officially kind of assigning 5 of them, the first 5 that have videos. But honestly, I'd love you guys to be able to work through all 9 because some might show for us later, all right? So that's your assignment. You guys have a good day. Treat the sub well. And while I'm here in the Alps battling a Yeti, I will be thinking of you guys. And I'll see you guys later. Yep, I'm battling a Yeti.